Welcome back to our series on the environmental consequences of engineering design. In this session, we will look specifically at environmental issues associated with transporting engineered products, materials, and assemblies, with a spotlight on the environmental costs associated with air, truck, rail, and ship transport. In previous sessions, we looked at high-profile natural extraction issues associated with the production of electronics products, such as the choice, often placed in engineers' hands, of whether to source gold, tantalum, tin, and tungsten from conflict-ridden or conflict-free regions of the world. We looked at the manufacture of products and assemblies, specifically those that are electronic, and the immense water usage involved in producing everything from printed circuit boards to tiny integrated circuits. In this session, we advance in the life cycle of electronics and other products and designs to the transport of goods of all kinds, whether by truck, by ship, by rail, by air, or by passenger pigeon. The process of moving engineered products from their point of origin to their point of use has costs, not just monetary, but environmental as well. For starters, in a world where millions of man-made things rely on petroleum to work properly, transport rises to the top of the bad actors list. At the bottom line, transport consumes more petroleum than any other activity in the world. And as one would expect, it incurs a wide range of environmental consequences as a result. While in general, the more miles something travels, the more harm it does to the environment, this is not always the case, because some forms of transport simply cost more in environmental terms than others. Regardless of the ultimate impact of greenhouse gases and the many arguments surrounding those impacts, carbon dioxide and equivalent greenhouse emissions into the atmosphere creep steadily upward. Transport plays no small part in these greenhouse gas emissions around the world. Unfortunately, direct comparison between different types of transport is difficult and often not appropriate. Consider transport by ship, for example. Ships moving in open water emit an impressive 40 grams of carbon dioxide per metric ton of cargo per kilometer of travel, but only 0.5 grams of nitrous oxides. While both are considered greenhouse gases, nitrous oxides are 300 times more damaging to the atmosphere. Thus, ships find the equivalent of almost 200 grams of carbon dioxide equivalent emissions per ton per kilometer. In comparison, in total amount, aircraft emissions appear to be trivial, but considering both the potency of nitrous oxides and the fact that greenhouse gases are much more damaging at the high altitudes at which most airplanes emit them, the equivalent greenhouse effect incurred by airplanes is tremendous. Fortunately, cargo transported by airplanes is a mere 1% of goods transported worldwide, and for this reason alone is not a major contributor to the environmental costs of transport. Rail, on the other hand, is a major supporter of transport of goods, materials, and products of all kinds, and greenhouse gas emissions from rail are quite tame, especially compared to its close relative, the semi-truck, which spews nearly 140 grams of carbon dioxide and 900 grams of carbon dioxide equivalents in nitrous oxides per ton per kilometer. Not surprisingly, truck transport is a top-rated bad actor in the greenhouse gas emissions business. In the big picture, ships look like a pretty good way to travel and transport, but probing deeper, we find that ships look good only for large volumes of cargo that exploit economies of scale, and only if we evaluate the numbers that are available on a meaningful scale for transport. If we look at those things that aren't particularly well quantified across ship transport of all kinds, we find some reasons for concern. For example, once out to sea, ships routinely dump large quantities of solid waste in the ocean, and although there are guidelines and regulations regarding the type and volume of this waste, there aren't nearly enough resources to enforce these regulations. And so what really goes into the ocean, no one really knows. The same is true for bilge water, that until recently ran through oily and dirty ballast tanks, taking an unseen volume of pollutants back to the ocean during every purge of the tanks. And so on the story goes. As ships transport invasive and non-native species across all the wet corners of the globe, and accidents have no small contribution to the overall environmental impact that these ships make on a vast and unsuspecting ocean. Looking at the environmental costs of transport from a different angle, at air pollution and more immediate impacts on human health, the picture is equally damning. Hydrocarbons and particulates are both bad for individual health, both through short-term respiratory effects such as asthma and breathing difficulty, and longer-term through more systemic and chronic effects, including multiple cancers. Not surprisingly, trucks are the lucky winner of the Bad Actor Award in the air pollution category of environmental consequences. Yet trucks and road transport remain our primary modes of transportation for goods and products of all kinds, all over the world. The bottom line for trucks is bad news. Trucks are louder, smellier, hotter, and more dangerous than all other primary forms of transport, making them almost always a poor choice for getting things from one place to the next, especially when rail is available to make the same journey. Ships, while not as clearly damned as trucks, have a broad number of unknowns that make it difficult, if nearly impossible, to evaluate their environmental costs and consequences. Ships make sense when large volumes are involved in certain cases, but the many opportunities for ships to pollute both air and water make them at best a murky choice for transport in terms of both environment and public health. And aircraft, while to the untrained eye may not appear that bad, are also near the bottom in terms of environmental consequences of transport. Amplified greenhouse gases, the many externalities of airports, and the costs of getting an airplane in and out of those airports all add up to a similar problem as with ships. Without a doubt, aircrafts pose substantial environmental costs, but the exact natures of those costs per ton of transport remains ill understood. This brings us to using what we can know to find a solution. What can engineers do? As with other environmental consequences, the first step in reducing those consequences is to better understand them. In the case of transport, this simply means understanding the supply chain. For a particular design, product, subassembly, whatever it is that the engineer is a part of, understanding where it is coming from and how it's reaching the end customer, or in the initial stages of design, the engineer himself, is essential. This is the first step. Once the supply chain is understood, it becomes possible to influence that chain to do less harm to the natural environment, and oftentimes to less harm to public or human health as well. Just like farmers markets, buying local, whether it be food or inorganic materials, products, and assemblies, reduces the overall economic and environmental consequences of transport. And given the choice, transport by train trumps transport by truck. Rail wins the competition for fewer greenhouse gases, less air pollution, lower noise, and a range of other environmental metrics. And while not as crystal clear as rail, ship transport is likely to be a friendlier mode of transportation than trucks as well. With fewer greenhouse gas emissions and less air pollution, ships may well still be better than trucks, although increasing data on the transport of non-native species, the dumping of solid waste, and the pollution of the world's oceans may ultimately suggest otherwise. At the design phase, engineers can also have an impact on reducing the environmental consequences of transport. Less weight means less cost, both economic and environmental. So designing for reduced product and design weight can almost invariably reduce the costs of transporting those designs. And this is an aspect of product design that engineers almost always have some control over. The same is true for packaging. While not always the task of the design engineer, packaging design comes up during the product development process and is addressed eventually by an engineer. If that engineer happens to be you, it's a golden opportunity to once again limit the environmental consequences of the many things that we engineer at a fundamental level to better society. In summary, any engineer involved in purchasing or requesting the purchase of a part or product has a voice in reducing the environmental costs of transporting those parts and products. An engineer, design or otherwise, can often have an influence on choices to buy locally or to buy from fewer suppliers. An engineer can often design or redesign for lighter weight or can choose environmentally friendly packaging. An engineer can, in concert with planners and other professionals, strategize to prefer rail to truck transport, and the list goes on. While these are often things that design engineers rarely think of or address, an engineer with an eye to environmental consequences can shift the tides to reduce environmental costs, part by part and product by product. This concludes our snapshot of the environmental consequences of transport in the world of electronics, technology, and beyond. Thank you for joining us today. We certainly hope that this session has provided additional insight into how the engineer can reduce the environmental impacts of transporting goods, and that you'll join us again as we look at other examples of environmental consequences in this series on real-world considerations in engineering design.